Welcome, cool kids of Algebra 2, and it's time to start Unit 5. And we're going to start off with basically old quadratic and something called the discriminant. So let's start off with the old quadratic formula. If you remember, the formula is basically written this way here. We've got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. We're going to pay close attention to part of that in a moment. Do me a favor, pause the video. Let's see what you can do with this one. See if you get it right. Give you a few seconds and I'll pop the answer on, so pause it. Alright, so hopefully this is what you did. I threw it in. Your a is 3, b is 5, c is negative 2. Did the math, ends up being a nice perfect square under the radical. Pull it out, and remember you do negative 5 plus 7 divided by 6 and negative 5 minus 7. So you should have gotten 1/3 reduced and negative 2. If not, take about piece by piece and copy the notes here. And we're going to go on to the next example because this is just review. Alright, our second example, basically the only thing is everything's not on the right side here. So you have to remember to bring the 8x over. Bring over the 1 to the left side. So if I rewrite it, it'll be 4x squared minus 8x minus 1 equals 0. Now we do the quadratic formula. So there's my a, my b, and my c. So x will be equal to the negative of a negative 8 plus or minus the square root of a negative 8 being squared minus 4 times a is 4 times c is negative 1. And that whole thing is over 2 times a, which is 4. So you would get a negative 8 plus or minus square root, basically 64, and then that's going to be what, plus 16? So it's going to be square root of 80 divided by 8, which equals a negative 8 plus or minus. Now, square root of 80, remember, is 16 times 5. So square root of 16 is 4 comes out, 5 stays under the radical, all divided by 8. And then me personally, I would just clean this thing up because it's not going to fully go away. Use my old V style here, and 4 goes into all of those. So my answer is going to be a negative 2 plus or minus radical 5 all over 2, because you divide 4 into each of those. And the 1 is in front of the radical 5, we don't need to write. So that's how you get your answers. Now, we're going to go into some different answers and things, and we talked about this before, and you're finally in the chapter that does it. We're going to deal with imaginary numbers, called complex numbers in this chapter. And we're going to talk about roots that are not only real now, so we're going to get into the other realm. So I got a little thing about this down below for you. There's this word called the discriminant. You can fill this in on the bottom of your paper. So the discriminant is a name given for the expression that appears under the radical sign, basically, the square root in the formula. The discriminant is the part underneath. So it's the underneath the radical is the b squared minus the 4ac. And that piece is going to tell us something. So that's 4ac. Okay? It's going to basically tell us all about the roots of the quadratic equation. And they can quickly tell me different things about them. They can tell me whether if they're imaginary. Actually, they're supposed to say or real roots. In other words, the number of roots. Or the types we're going to talk about as well. Okay, I have a quadratic equation. So, let's take a look at it on the next page. See what we got. I got a couple more slides to go. So, what we got here on this page is a nice little diagram that will help you out. There's 4 situations with a discriminant. If we actually figure out the b squared minus 4ac and you get a number, that's called your d. If it is bigger than 0, and that number is a perfect square, like we did in the one example was 49, you're going to get 2 real rational roots. Meaning they're not imaginary, just like we've always got. We get 2 roots, and they'll come out decent numbers in that. They'll cross nicely here and here, roots. They won't be radicals or anything like that. So those two, they'll be real, and they will be rational. They'll be decent ones, okay? If it comes out to be greater than 0, but it's not a perfect square, then obviously it's not going to come out from underneath the radical sign, so you're still going to have a radical left, so you will have two real roots again, okay? But they'll be irrational, because they're going to end, and they're not going to cross in nice spots. They'll sit here, but they'll cross between the nice integers, and you won't get nice answers out of them, is the bottom line, okay? You might get 1, but you might not get, 2 or something like that. If under the radical, the b squared minus 4ac turns out to be exactly equal to 0, well, that whole thing's going to fall apart, and you're going to actually just get one real rational root. We call it a double root, but basically it just hits the x-axis at one point. So you're going to have 1 right here, exactly at that point. Okay. And then the case that we always stopped at, we said, what happens if it comes out less than 0? Well, if it's less than 0, it means it's negative, right? And up to this point, I've been promising you all the way along, we're going to deal with it eventually. Well, we're reaching that point now. If it's less than it, you get a negative under the radical, you're going to get what we call imaginary roots or complex roots, and also complex conjugates. So conjugates come back again in this chapter as well. We'll play with it. But bottom line is, the parabola comes down and goes back up, or it's an upside down and never quite reaches, so it never hits the x-axis, meaning you never have any roots. So any real roots, now we're going to actually discover. They're called complex roots. So let's take a look here. I'm going to switch this back to a pen here. And let's just go from the discriminant here. So if I'm going to do the discriminant, remember I said it was b squared minus 4ac. So in this case, my a is the 1 in front of the x squared. My b is the negative 12. And the c does not exist, is it? It's a 0. Because there is no number by itself here. So if we plug these in real quick, I get a negative 12, which I am going to square, minus a 4 times a 1 times a 0. Well, anything times 0, this whole thing's going to 0 out, so the bottom line is get 144. Well, isn't that a perfect square? And if that's a perfect square, which case is it? Correct. Perfect square up here is bigger than 0. 144 is bigger than 0. We're going to get 2 real rational roots, okay? And that's all they're asking you for on something like this. So we're going to have 2 real roots here. So 2 real rational, I'll abbreviate, roots. So that's basically what we call case 1 up there. You don't have to memorize these by cases. All right, I want you to pause the video. I'm going to do it while you're pausing it. Do number 2 and see if you can figure out which case. Okay, so hopefully you figured out A, B, and C right here. Is what I had here, a 1, a negative 3, and a 4. You plug them in, do the math. Negative 3 squared turns out to be 9. A negative 4 minus times a 1 times a 4 is a negative 16. And when I subtract, I get negative 7. Well, negative 7 means my D is less than 0, so it's the last case right here. We're actually going to get then 2, okay, complex roots, we'll call them. Or you can call them 2 imaginary roots. Okay, even though we still don't know what that really means at this point, other than it's a negative under radical, that's what we're going to get. Okay, one more slide of practice, and then we'll finish to the day. All right, so I got 4 more examples for you. Going to do maybe 2 more with you, and then I'll have you do 2 on your own, and we'll check that to make sure you did that as part of the video. So why don't you pause the video and do number 3 and 4, and we'll see if you got those right, and then we'll go on from there. Okay, so if you did the work what I had, I turned out, and this first one right here turned out to be a 0. So if you go back to your little chart on the previous page on your notes, it tells you have 1 root, meaning the thing comes down, the parabola comes down and hits the x-axis at one spot and goes right back up. And because it's positive, I also know, remember from back in 9th grade, it's right side up, so we already know that, or you can plug it in your calculator. Second one here, number 4, turns out to be a negative, so that's going to be the case of the last one. These are 2 imaginary or 2 complex roots. I'm not asking you for the actual answer, I'm just telling you asking you how many and of what type. So those are 2 complex roots. That one, number 3, had 1. So I want you to do 5 and 6 to finish up your homework, and then I'll see you in class tomorrow, and we'll roll with this. It'll be pretty easy, making you feel good about what you can do here. Have a good evening.